When we talk about responsible AI testing of generative AI models, the first important thing to remember is that in many cases, it is legally required today. So what we're going to cover here are some of the new regulations and laws that you need to be aware of when building real systems, some of the challenges and gaps where current LLMs do not seem to comply with these regulations, at least not out of the box, and an automated testing library, open source library that can help you generate and execute tests to meet those requirements. So, first of all, bias is one of those areas that legislators have already tackled in quite a few industries. For example, bias in medical AI algorithms is now explicitly illegal in the USA. The ACA Section 1557 became law in June, and among other things, it prohibits covered entities, which means basically everyone who provides healthcare to people, from discriminating on the basis of race, color, national origin, sex, age, or disability. This applies both to kind of complete AI algorithms, but the definition is fairly broad. So even if you had a case where kind of there is human review, right, and you recommend something and a human makes a decision, even if your AI system is basically just a set of rules, this also applies. So it's a fairly broad definition of any computer system that helps make patient care decisions. Another area where new legislation is coming into place is in employment and recruiting. The state of New York passed a law, New York Local Law 144, that is in effect already, that requires any tool used in recruiting to be audited by a third party for bias, safety, and accuracy. It requires the information about the model and about that audit to be made public, and in some cases requires some transparency to candidates about what's happening with the tool and with their data. Last fall, California Supreme Court decided that they don't need a new law. They can already hold both AI vendors as well as companies who buy those tools liable for biased job screening, right? Basically, kind of says, look, with existing laws already, you cannot call it new technology and now allow it to bias people based on their age, gender, or other things that you're already not allowed to discriminate job candidates for when they apply. Quite a few government agencies, as well as the American Bar Associations, came up with guidance basically explaining that when dealing with employment, bias has been illegal for decades, and there are quite a few rules that already dictate that no matter if you do this manually, you do this automatically, you do this with generative AI or however else you call it, you are not allowed to discriminate people based on gender, age, pregnancy, religion, color, based on whether or not they served in the military, based on whether or not you have genomic information about them, pregnancy, disabilities, all of that is already in place. And this is something that if you're building a model, it's your responsibility to make sure that the model complies with all of these rules. Another area other than bias that's becoming a focus area now is accountability and transparency. Transparency means two things. One, are you transparent to people in the sense of telling them that an AI model is used to evaluate them or an AI model is speaking with them, right? So making sure that, for example, if you're using an algorithm to make an insurance decision, a banking decision, a housing decision, employment decision, people have the right to know that it's happening, and in some states also a right to an explanation, right? So explainability is still in some states now actually a legal right that we all have. Another type of transparency is requiring the algorithms, the models themselves, to make some information public. How they were trained, who owns them, what models are they based on, what features do they use when making decisions, right? And who can you sue if you think there is a problem. So you can see here some of the requirements from Colorado, from Utah. Both of them place liability on both companies training the algorithm, as well as the companies who buy and use them. In regulated industries, there's been quite a few agencies in the US who came out and says, look, this is already in effect. So if you're looking at consumer protection, if you're looking at privacy protection, if you're looking at health insurance decisions, or you're looking at how banks need to manage risk, the key thing, and I think that there was the FDIC said it best when they talk about banks. Look, this risk with computers technology, we already decided how we do this back in the 60s when computers started happening. And it doesn't matter what technology is used. If you're a bank, if you're an insurance company and you're making decisions with technology, those are still your decisions. You need to have the right risk management policies in place. You need to have the bias mitigation in place, of course, the accuracy and reliability in place before you deploy any kind of system. So in short, in quite a few industries today, if you're either building AI or buying AI, and AI could be anything from a large language models to just a bunch of business rules, it is your responsibility to do two things: to test that the models are compliant with existing regulations and laws, as well as to be able to show, in terms of transparency, to be able to prove to regulators and sometimes prove to the courts or to end users that your models actually work, so that they are accurate, they are safe, and they are unbiased. And with that, what's interesting is that when you look at generative AI today, there are actually some obvious gaps. So for example, current large language models, and I'm talking about the current state-of-the-art models that are out there, are biased. They show gender bias, they show racial bias, they show bias towards people where English is not the first language, and people with disabilities. If you're looking at visual models, they're even biased towards people who are not as pretty. And this has been shown in quite a few papers, and they're really basically any way you try to show it, it comes out, and it shows that the biases are there. What is problematic from an implementation perspective is not only are LLMs biased, they are very visibly biased. So here's one example that we ran on a healthcare case. And what you do here is you have the history of a patient, and then the question is, what would you recommend? Is follow-up medications, follow-up tests, and lifestyle changes. And within the whole patient story, it's enough to change one word, from Asian to white, from homosexual to heterosexual, and suddenly the recommendations on how you should manage your diabetes changes. So, and that's not only wrong clinically, and not only illegal, it's also very easy to show. So if you need to show it to a judge, show it to a jury, it's look, try it on your own phone, change this one thing, and you see the model changes it. Try it with your own parameters and see what you get. So it's a very kind of in-your-face way of breaking the law. Another challenge with large language models is that because they handle free text and you can talk about anything, there are more types of biases that you need to check for. So classically, when you look at structured data, most of the biases that people measured or cared about are age, gender, and race. And that's for the simple reasons that those are things that we actually collect, right? So if you want to know whether we are, where we are biased by gender in, deciding who gets a mortgage, one reason you can even do it is because you have the gender field in the database when you make the decision. Same goes for race, same goes for age. But if you only looking at structured tabular data, you just don't have a field for disability status, for pregnancy, for height, right, for socioeconomic status. But if you process the whole application, which is free text, or if you listen to a conversation, you make a decision, like a recruiting decision, marketing decision based on that, what you'll see is that you also need to worry about stereotypes on what the profession is. Are you a doctor or are you a janitor? What kind of house do you live in? Are you married? Are you disabled in some way? Do you stutter? Do you have an accent? So there are many more types of stereotypes that LLMs embody and that we need to check for. Other than bias, another non-issue with current really state-of-the-art LLMs is around reliability and robustness. LLMs are fairly fragile, and there are quite a few papers. Here's an example from one of them that show that very often, if you can change really one or two letters within a long prompt, which will really lead the LLM to return a completely different response, right? In this case, this paper looks at problems in mathematics that shows that it's enough to add two typos to get the algorithm to give you the wrong answers on fairly simple math questions. It also showed that if you change words to synonyms, so instead of review this statement, analyze this assertion. So changing synonyms makes the model change its mind on fairly simple document classification issues, right? Like sentiment analysis. And we do have this problem in general where very slight changes to the prompt or very slight changes to the text cause LLM to completely reverse their answers in many practical situations. And this is something we need to test for and something we need to train for, right, for the LLMs. On top of it, we know that large language models also require new types of safety testing. Just like bias, you do have a problem with traditional bias, but you also have new types of biases to worry about. It's the same thing here with reliability and safety. So now we do need to worry about hallucinations. So this is something we need to test for, something that we need to make the models, basically strengthen the models so they do not fail for. So of course, classic hallucinations is generating complete lies, complete fictional information, but other issues are really just making assumptions that are too far-reaching, or really just sometimes returning an answer and just being too confident about it, right, and not reflecting the real uncertainty in the situation. This information is another issue. With different types of either prompt injection attacks or really just data quality with the source issues, you can get LLMs to repeat and amplify false information if that's what the attacker wants. Toxicity is another issue. You need to make sure that when a generative AI algorithm replies in a customer service setting, it is not using swear words, it is not using obscenity, it is not using a threatening voice. And that can happen because LLMs tend to mimic the style of conversations that you have. So if you attack the LLM, it's more likely to attack you back, which is something that you need to be careful about. And another type of safety testing, and of course there are more, is private data leakage. Okay, so basically trying to convince the LLM, especially if there's a RAG or database in the background, to disclose sensitive information that it should not disclose. So we know that we have new legal issues, and more of them are coming. And by the way, at this point in time, 26 states in the US have legislation specific to artificial intelligence. Of course, it's much more legislation that's been proposed and probably will come within the next 1 or 2 years. In Europe, of course, we have the EU AI Act, and in other countries that's happening as well. We know that the current large language model, if you just take an LLM, take an API, take an open source models, you are going to run into problems. So what you need to do, you need at the very least to have a way to test those models for all of those problems. And once you find the problems, you need to fix them, right, with data augmentation or other techniques. So one tool that you should be aware of, it's the LangTest library. LangTest is an open source Python library that's designed to automate LLM testing for custom LLMs and custom systems. Okay, so if you want to compare, GPT-4 with Llama 3.1, there are lots of libraries that do public benchmarking, right? That give you, they do head-to-head comparisons and will tell you in general how these models do on public benchmarks or academic benchmarks. LangTest is designed for the case where you want to test your own system. So you're specifically making a lending decisions, right? You're deciding which marketing promotions to show to someone. You're deciding, what pricing to offer someone who's looking for a mortgage. And this is your own system. It's custom. It can be an LLM. You may have fine-tuned it. Maybe it's a combination of guardrails, the LLM itself, your own prompting, and the RAG system in the background. But the point is, at the end, you have built something custom, and you need to be able to test that system and make sure it's safe, accurate, compliant before it goes to production. So the goal of LangTest is to enable you to do it in a simple way, in a few lines of code, but also really be comprehensive. And there are more than 100 test types available right out of the box. What LangTest does is automate 3 steps in your AI workflow. So basically, instead of going from training the model, I train the model, I have the test set, I have the metrics, kind of works on my machine, okay, go deploy it. We have 3 more steps. First of all, we generate tests. And what's cool is that with Generative AI, you can automatically generate many of these tests, especially for robustness and bias. And what we do, we build a test suite that can have usually at least several thousand tests for one use case. The next thing we do is we run the tests, and then one of 2 things happens. Either the test pass, so basically they're good enough for us to release the model to production, or they don't, in which case LangTest also enables you to automatically generate synthetic data to augment your model. Okay, so that, for example, if your model does not do well with, for example, people with Hispanic names, you can generate more training data with those names specifically, go retrain your model and try again. LangTest is designed to enable you to use pretty much any LLM out there, right, whether commercial or open source. So you have access to all of these APIs. You have access to also local and of course, and open source models. And you can test all of these models using the same test suites. You can also compare between them, right? So you can kind of say, look, I'm comparing, say, OpenAI, Cohere, and Anthropic. You can do it on the same test suite. You can run it as one line of code and see the comparison. The basic use of LangTest is very, very simple. The key class is the harness class. The harness class encapsulates a test suite and the results from running it. And the simplest thing you can do in 3 lines, of course, is this. You import the library, you create a harness, and you tell it which model you want to test from each hub. Okay, as I mentioned, right now there are 12 hubs that are supported. And then you have this line of code that first generates a new set of test cases. Okay, this is based on a default configuration. Then, of course, if you want, there's a file, you can change it. After generate, you call the run method, which actually calls the LLM inferencing, right, and runs all of these tests, all of the tests in your test suites, and then compares the expected result to the actual results. The third thing you need to do is create a report, which means generate a summary report saying, what has passed, what hasn't, really overall how well your model is doing. These 3 lines of code are all you need to take. For example, in this case, this is simple BERT-based models, generate tests, run them, and see how you're doing across all of these dimensions, right? So bias, accuracy, fairness, representation, toxicity, and others. So when you generate tests, the key notions are that you can auto-generate the tests for quite a few categories. There are more than 12 types of categories and 100 types of tests for different aspects, from name, religion, gender, ethnicity, coverage, data leakage, accuracy, toxicity, security, and so on. Once you have a test suite is basically a table. And one very important concept is the test suites are human readable and editable. Okay, so here, for example, you can see, and this is something you have as a data frame, and you can just export it to Excel so that the human can just edit it and change it. And you can see, okay, one test type here is we add a typo. Okay, so instead of Wang Li is a doctor, we say doctor. We still expect Wang Li to be extracted as a person, right, as the person we're talking about. We can add context. We can replace Wang Li to Juan Moreno, to a Hispanic name. We can require a minimum representation, right, to female in the test data set, right, or minimum F1 score specifically per gender. What's very important is that while we can generate the test automatically, sometimes human experts want to be able to, first of all, read them. And it's very important if you have a test suite and a regulator comes in or a lawyer comes in, you can say, oh, you want to see how I tested for bias? Here. I ran these 4,500 tests. But it's also important sometimes for domain experts to look at it and kind of say, well, okay, this test is, it's not quite right. I wouldn't say it that way. Or, that's a good idea. I want to add a few others. Once you run the tests, you call run and then you call report. you see if the, like any test, you call LM inference and you see if what was returned equals what was expected. It's not always direct equal, because when you have question answering, sometimes you just want to be semantically close enough, and there are different types of semantic distances that the library supports. Once you have your results, you compare the actual pass rate with what you defined as the minimum pass rate. So if, for example, in this case, you decide that for this model to be released to production, I need at least 75% of my robustness test to pass. In this case, this model will fail the test because only 50% of robustness tests overall have passed. So you can do this definition per category and really decide if your model is ready or not. The next thing you can do is integrate all of this into your CI/CD or MLOps process, so that you're not only testing the first version, you're testing every version of the model, right? Because of course you do experimentations, you keep changing the model, maybe you have feedback for users, maybe a new LLM comes and you come and say, well, okay, what if you now instead of Llama now we use Qwen? Can we do, is it going to do better? Well, just run it on the test suite, right? And let's see how well we do. You can script it really using any MLOps framework that you want. But once you've trained a new version of the model, it's a one-liner, either from Python, from a command line, to basically run a regression test, right? Load this previous test suite and run it on this new model. Give me the report, tell me whether or not I passed and which categories passed. And of course, only deploy if the test has passed your threshold. Another thing that we're happy to announce now, and now is becoming available, is taking all of that and moving it from a Python library to a user interface. And within this user interface, as you can see, you can create, you can share, you can reuse test suites. You can attach them to projects. So you can define basically test projects because, as I mentioned, this is designed for custom models, right? So you may have your own models that you build locally. You may have your own endpoints that you're looking to test, so you can do that. You can automatically generate the tests. You can automatically run them, of course. You can inspect the results and drill down all the way to the individual result. You can compare multiple versions, right, and run the same test suite across multiple models. And of course, store results across different versions. So the goal of the user interface is twofold. First of all, enable a really non-technical domain expert to do this. So for example, if you have a medical model, you need medical doctors to be able to test it, right? They need to be able to understand the test suite. They need to understand, what do you mean by testing for bias? What do you mean by testing for toxicity? Show me the tests. I want to read them. I may want to edit them, right? I may want to extend them, right? And then I can see everything running. The second thing that a user interface does for you is it enables you to automate best practices. Okay, like the fact that a test suite should not just be a file, it should be versioned, it should be shared, it should be reusable, it should be, of course, executable and something that you actually execute, right, as part of every new iteration of a model before it's deployed. And it should be private, right? So when you have your own use case, of course, it's custom to you. You want to usually keep the tests private just to make sure you don't train a new version of the model on your tests. Which is kind of a classic form of contamination, which is why it's important to be able to very easily and automatically generate your own tests and do that. So this tool is available now, right, on top, of course, the open source LangTest, which we keep working on. And when you think about it, when you think of whichever tool you develop, really you should have a whole framework in place. And today, there are a lot of tools and a lot of startups that are competing on helping you with governance. Governance basically means making sure that you have a process within your company where you actually know what the legislation is, because you track it and you get updates. You have policies, so just like you have cybersecurity policies, you have AI bias policies and AI transparency policies and AI release management policies, right, for all of these models. That makes sure you comply with legislation. You have some risk management in place, and if there are transparency requirements, right, you have to disclose that you're using AI to your end users, to regulators. That happens. But governance is only maybe 1/4 of the picture. The second fourth is actually testing the models, right? So just like cybersecurity, it's nice to have a policy that says we will not have vulnerability. The next thing you need to actually have a vulnerability scanning tool. And this is what the LangTest open source library does. It provides you a tool to actually test your models for a very large variety of aspects, right, within responsible AI. You need to have these tests. You need to know that the right ones. Also, even if it's automated, you need at least some manual reviews that you can explain it to a regulator. You need to automatically execute them, and you need to make sure that the versioning and the audit trail is there, really just like we do for traditional unit testing. The third aspect of your responsible AI framework needs to be on monitoring. Once the model is in production, you need to measure bias in production. Okay, so it's nice that within your test environment, there's no difference between males and females. But if in production there's a bias, then yes, you should get into legal trouble, right? Because but what's important is how well the system actually works, right, for its end users. You need to measure drift, you need to measure safety and data quality, and you need to provide some explainability to your own team and to end users. So that's another set of tools that's really people are just beginning to think about. And the fourth aspect is audit. What's happening more and more, especially in regulated environments, is that companies are required to have third-party audits on bias, on safety, on accuracy, and other claims that they make. So that's kind of the fourth area. And if you're really thinking about how responsible AI will look like this year, next year, definitely in the future, think about a solution for each of these four aspects. And with that, I wish you the best of luck with building real-world systems that are not only accurate, but also safe, unbiased, and trustworthy by their end users. Thank you.